Jai Hind students, welcome to my YouTube channel. Students, always believe wholeheartedly in the virtues of loyalty, trust, sincerity, dedication. These all are the qualities which as human beings we must possess. Life, students, as you are aware, it is full of crests and troughs, isn't it? It's not smooth. At times we might feel low, and at some other time we might feel very happy. But the true character of a person lies in maintaining his coolness, calmness and remaining happy in trying circumstances. Right, students? So let's begin this session, and in the previous lecture we have discussed case 3. That was the case of angular projection, isn't it? When a body is projected with velocity u making an angle theta with the vertical. Now again in case 4 we will be discussing angular projection but from a height. So case 4 is when a body is projected at an angle theta with the horizontal downwards from a height. So this is the scenario basically. This is the situation. This is suppose the tower or a building, and this is the ground. This is the top of a tower or a building, right? So this is an imaginary line. It is parallel to the ground, so it may be treated as horizontal. Now it is projected with velocity u, making an angle theta with the horizontal and downwards, right? So we'll prove that in this case also we'll tend to follow a parabolic path like this. We'll tend to follow a parabolic path. So suppose the height is given to be h. This is the height of the building or the height of the tower under consideration, and this, students, it will be the range. This is obviously the range. Range is, as we are aware, it is defined as the maximum horizontal distance covered by a projectile in the time during which it remains in air or space. So the time during which the projectile remains in air or space would be capital T. So capital T is the time during which the projectile remains in air. So that will be its time of flight, right? So now in order to determine the equation of trajectory, we need to resolve this u into two perpendicular components, right? So splitting up of a vector into two perpendicular components. This component, students, which is along the horizontal, it is the initial horizontal component of velocity, and it will be equal to u cos theta, isn't it? Now the other component, which will be in the vertically downward direction, here this is the initial vertical component of velocity. It will be equal to u sin theta. Now students, look, these are the two adjacent sides of a parallelogram, and its resultant is given by the diagonal of the parallelogram passing through the same point. So u is the resultant of ux and uy, right? And as we are aware, students, projectile possesses two independent motions, horizontal and vertical motion. Horizontal motion, it moves with uniform velocity. So along the horizontal direction, the horizontal component of velocity remains constant. So that's u cos theta. It will remain constant throughout. Here also it will be u cos theta. Here also it will be u cos theta. And at the instant when it strikes the ground, here also the horizontal component would remain u cos theta, right? Because acceleration along the horizontal direction is always zero, because no net force acts on the projectile along the horizontal direction in the case of a projectile, right? And second motion possessed by projectile is vertical motion, which is under the influence of gravity. So it is coming downwards. So the magnitude of the vertical component of velocity will keep increasing at a constant rate. So initially it has got this velocity. Now as it comes downward, its magnitude will keep on increasing. And at the instant when it strikes the ground, it will be maximum. This is the final vertical component of velocity. Clear? So this is increasing vertical component. while the horizontal component that will remain constant. So that's the basic concept, right? And at the instant when it strikes the ground, the resultant velocity will be given by this. This is the resultant velocity, right? Which will be the diagonal of the parallelogram formed by Vx and Vy. This can be considered to be the final horizontal component of velocity. I hope the diagram is pretty clear, right? Now suppose in time t, suppose the body has come over here, covering horizontal distance x and vertical distance y, right? So over here what we do is, we will consider motion along horizontal and motion along vertical. So let's see. So what we do is, basically over here, consider motion from, suppose this point is O, this point is P. Consider motion from O to P. Now let's consider along horizontal. Along horizontal. Okay, let's make use of second equation of motion. S equals to ut plus half at square. Along horizontal means along the x direction. Sx in time t, the horizontal distance covered is x. Ux, initial horizontal component of velocity, that's u cos theta. Time from O to P, time that is elapsed is small t. Ax is 0, so this entire term will get eliminated. Ax is 0, right? Ax is equal to 0, so this term gets eliminated. So t would be equal to x divided by u cos theta. You can put this as equation number 1. Now let's consider motion along vertical. Now here again, let's make use of the second equation of motion. Okay, Sy. Now students, it's a very important concept. It is covering displacement. If this is the origin, if this is considered to be the origin, so it is covering displacement towards the negative y-axis, isn't it? Towards the negative y-axis. So displacement over here, it would be equal to minus y. While solving numericals, please do make use of this sign convention. You need not to remember formulae for this particular article. You just need to construct the equation and make use of the proper sign convention. So here, this is the origin and this is the displacement covered by the body in the vertical direction, that is towards the negative y-axis. So the displacement towards the negative y-axis, that is minus y. Towards the positive y-axis, that is plus y, isn't it? So uy is u sine theta. Okay, t, the body is coming downwards, so it will be plus g, ay will be plus g, so half g t square. Put this as equation number 2. So students, as I have told you, if you substitute this value of t over here, you will get a standard equation of a parabola, isn't it? So we have mathematically proved that in this case also, whether it is the case of horizontal projection from a height or it is the case of angular projection from a height in the downward direction, again the nature of trajectory of the projectile is parabolic. So here you need not to remember any formulae. Just while solving numericals, which we will be doing in the later part of this session, we need to just make use of the kinematic equations and make use of proper sign convention. So directly we will attain the answer, right? So in these articles, you need not to remember any sort of formula, right? So these are the two equations which you need to construct using proper sign convention. Now students, for range, what to do is, consider the same equation. Now from O to, suppose this is point B, or rather A. If you consider the motion of the body from O to A, and if you take motion along horizontal, then you can easily get the expression for R. How to get it, I will tell you. Consider motion from O to A, right? And consider motion along horizontal. Let's consider motion along horizontal. So in this case, what we do is Sx is equal to uxt plus half ax t square. Now Sx, from O to A, the distance covered by the projectile along the horizontal direction, that is r. Ux, students, ux is the initial horizontal component of velocity, that is u cos theta. U cos theta. And from here to here, the total time taken by the projectile is capital T, which is time of flight. And ax is 0. So this will be the expression for the range. Right, students? And in order to find out the time of flight, what to do is, here, if y is equal to h, then if y is considered to be equal to h, then time small t would be equal to capital T. Or when t goes to capital T, then y would be equal to h. You can consider the vice versa. So if you substitute this value over here, what you get is minus h is equal to u sin theta, in place of small t replace capital T, plus half g t square. So what I mean to say is, students, in numerical problems you will be given the height or you will be given the expression or the value of the time of flight. So if height of the building is given, theta is given, then using this equation the time of flight can be easily determined, and then that time of flight, the value may be substituted over this equation so as to get the range. So in this article, no formula is to be remembered. Just try to understand the concepts and accordingly construct the equations as per the given portions, right? Net velocity over here, what will be its value? Now net velocity, as you are aware, it will be given by square root of Vx square plus Vy square, isn't it? So it will be equal to Vx, it will remain constant, it will be u square cos square theta plus Vy square. Now how to get the value of Vy over here? For that, students, consider again motion from O to A. Now if you consider Vy, it will be equal to Uy plus Ayt. So from O to A, at point A, the final vertical component velocity is Vy. What is Uy? It is u sin theta. Ay is plus g, the projectile is coming downward. Small t, from O to A, the total time elapsed is capital T. So substitute this value of Vy over here and you will get the magnitude of the resultant velocity with which the projectile strikes the ground. So again I repeat, students, just try to understand the concepts without bothering about to remember the formulas associated with this particular article, right? So in the case of angular projection, when a body is projected making an angle theta with the horizontal from a height in the downward direction, then also it is the case of a projectile, and the nature of path of the projectile must be parabolic. The nature of... Okay, students, now let's proceed with case 5. Now try to make out the difference between case 4 and case 5. Case 4 was angular projection from a height in which the body is projected with some velocity making an angle theta with the horizontal in the downward direction. Case 5 is angular projection from a height, again the same thing, but in this case the body is considered to be projected at an angle theta with the horizontal upwards from a height, upwards, right? So this will be the situation like this. This is the ground, suppose, and this is the tower or a building. Suppose its height is h, and this is an imaginary line which is parallel to the ground, so it may be treated as a horizontal line, right? So this is point 2, and here the body is projected with, suppose, say velocity u, making an angle theta with the horizontal and in the upward direction. Understood the difference now between case 4 and case 5, isn't it? In case 4, it was projected downwards, making an angle theta with the horizontal. In this case, it is making an angle theta and projected upwards. So now, obviously, it will follow a path like this. It will follow a path like this. Am I clear, students? So, in this case, this will be the range. This is the range. Right? And you can divide it into two parts actually. You can divide it into two parts like this. This is h, so this would be also h. Right? So we can resolve u into two perpendicular components, isn't it? This component would be u cos theta. This component would be u sin theta. Listen, students, always remember the horizontal component of velocity of a projectile at any point during its motion always remains conserved. So u cos theta, here it will be u cos theta. At the highest point, at the peak point, again the horizontal component is u cos theta. Here it will be u cos theta. At this point, it will be again u cos theta. Here at this point, it will be u cos theta. And at the instant when it strikes the ground, again the horizontal component will remain constant, that is u cos theta. All these arrows must be of equal lengths, indicating that the horizontal component of velocity of a projectile remains constant since acceleration along the horizontal direction is 0. Now vertical component, initially it is moving upwards, so what happens is vertical component velocity, its magnitude will keep on decreasing. At the highest point, the vertical component of velocity at the highest point would be 0. At the highest point, the vertical component of velocity of the projectile is 0. Net velocity is not 0. Net velocity at the highest point would be equal to the horizontal component of velocity. Right? So, here at this point, the vertical component of the velocity at the highest point is 0. Now, from this point it is coming downward. So, now the magnitude of the vertical component of velocity will keep on increasing at a constant rate of plus g, 9.81 meter per second square. Now students, we are aware, at this point, this was case 2, isn't it? You must remember case 2. There we have proved that if this is u sin theta at this point, on coming at this point, the vertical component of velocity will have the same magnitude but in the opposite direction. So if it is u sin theta, at this point it will be u sin theta in the downward direction, like this. It will be u sin theta. Now from this point, it is actually case 4, just previously what we have done. So now it is coming downward, the vertical component of velocity will keep on increasing, and at the instant when it strikes the ground, it will be maximum. It will be like this. Clear, students? So actually this case 5 is the combination of case 2 and case 4. This is case 2 and this is case 4. Right? The combination of these two. So points to be noted is that the horizontal component of velocity throughout it remains constant, while the vertical component of velocity, which is under the influence of gravity, will increase or decrease at a constant rate, and that constant rate is small g, which is acceleration due to gravity. When moving upwards, its vertical component of velocity will become decreased, and at the highest point eventually it will become 0, and on coming downward, the magnitude of the vertical component of velocity will keep on increasing, and at any instant the resultant velocity would be given by the diagonal of the parallelogram formed by Vx and Vy. This is suppose Vy, final vertical component of velocity. So you can draw a parallelogram over here like this. This is the parallelogram. So its diagonal, that will give us the resultant. Clear, students? These all are the things which we have done. So again, in article 5, or rather in case 5, you need not to remember any sort of formula. Just make use of your common sense. Suppose from O to point B, and this is suppose point C. So what about the total time of flight then? Total time of flight. It would be equal to time taken by the body to move from O to B plus the time taken by the body to move from B to C. O to B, we are aware it is 2u sin theta divided by g. This is the result which we obtained in case 2 plus TBC that can easily be found by constructing the equation which we have discussed in the previous case, right? So this will be the total time of flight, right? What about the maximum height? This is h, this is h, this is h, and let us consider this to be h dash. So what will be the maximum height then? It will be equal to h dash plus h. So maximum height attained in this case would be equal to h dash. Again, in case 2, we are aware of the formula for the maximum height, isn't it? It is u square sine square theta divided by 2g plus this height, which is the height of the tower or the height of the building. So it will give you the maximum height attained by the projectile. What about the range? It is r dash plus, suppose this is x. Okay? This x, its value is determined just in the previous article. So what about the range? Net range. It will be equal to r dash plus x. So net range in this case would be this one, this distance. This is the range as was obtained in case 2, which is u square sine 2 theta by g. So it is u square sine 2 theta by g plus this range. This we obtained just in the previous case, right? Plus x. So basically, students, again I must repeat, you need not to remember any formulae related to case 4 and case 5. Just you have to make use of your common sense, and your theoretical concept should be pretty clear. You have to construct the equations, right? So basically here, while constructing equation, I'll tell you a method, right? If you consider motion from O to C, let's consider the motion from O to C. Clear, students? From O to C. During this time, the body is covering this vertical displacement. This is the origin. So this is the vertical displacement covered along the negative y-axis. Remember that. Let's make use of the second equation of motion. S equals to ut plus half at square and along vertical. So Sy, during this time, the vertical displacement along the vertical axis, and it is along the negative y-axis. So it will be equal to minus h. This is a key point, student. Please remember this, right? While solving these questions, we will be directly using these equations, and we need not use these things, right? Just construct the equation and apply the proper sign convention. What is uy? Uy is u sin theta. It is the initial vertical component of velocity at point 2. It is u sin theta. What about t? This is the total time of flight. Let us consider it to be t only. T here, small t, is the total time of flight. Plus half. What is ay? Initially it is moving in the upward direction. So it is minus g and t square. Here small t is the time of flight. Total time taken by the projectile from O to C. So in case h is given, theta is given, u is given, t can be easily found, isn't it? And when t is obtained, then the net range can also be easily determined, right? And in case time is given, theta is given, u is given, then height of the tower can be easily determined. So students, what to do is, let's attempt these two questions which are based on case 5 only, right? Try to read that question. Question is, student, a stone is thrown from the top of a tower with velocity of 16 meter per second. Well, this velocity is given to be 16 meter per second. right? We are dealing with the first numerical. At an angle of 30 degree with the horizontal, this theta is given to be 30 degree. It is given to be 30 degree. So this is the valid diagram. Okay. In the upward direction, it's projected in the upward direction. So it will follow a path like this. The nature of trajectory would be obviously parabolic. The stone takes 4 seconds to hit the ground. So from point O to point C, the stone is taking 4 seconds. It will be the total time of flight. Let us consider this to be t only. So it is 4 seconds. From O to C. O to C. Total time taken is 4 seconds. Calculate the height of the tower. So we are supposed to find out the height of the tower and the range. Right? So let's do it. We are aware of this equation, students. Again, I'll explain. Consider the motion from O to C. Consider the motion from O to C. And let's make use of the kinematic second equation of motion along vertical direction, because h is to be found. So it is s equals to ut plus half at square and along y component, along y direction. So in time small t, the body has covered vertical displacement of h towards the negative y-axis. This is the origin, this is the negative y-axis. So that is why it is taken as minus h. uy, it is the initial vertical component of velocity, which is u sine theta. T, it is the total time from O to C, plus half. Ay is replaced by minus g. Initially the projectile is projected in the upward direction. So let's substitute this value over here. So I'll write down the equation. So minus h is equal to u sine theta t minus half g t square. Right? Okay. Let's solve it. Minus h is to be calculated. U is given to be 16. Theta is given to be 30 degree. Sine 30. T is given to be 4 seconds. Minus half. Suppose G is, take G as 10 meter per second square. Right? So here we will take 10 multiplied by T is given to be 4. So it will be 4 square. Right, students? Okay. Let's solve it now. So minus h is equal to 16. Sine 30 is half. Minus half into 10 into 16. So what we get is minus h is equal to 32 minus 160 by 2, that is 80. So minus h is equal to minus 48. Minus minus get cancelled. So h would be equal to 48 meters. So this is how such numericals need to be attempted. It's very simple, students. No need to remember any formulae. Just make use of the kinematic equations of motion and apply the concepts by drawing this relevant diagram. Right? So this is the height. Now second part. Calculate the range of the stone. This is to be found. So what to do is, let's consider motion along horizontal. Let's consider motion along horizontal. Now let's consider second equation of motion. Sx equals to uxt plus half ax t square. Now from O to C, so total horizontal distance covered is r, which is to be determined. Ux, students, it is u cos theta. U cos theta. Small t, it is the total time of flight from O to C. Ax is 0, so this term entirely gets eliminated. Isn't it? Just make use of the theoretical concepts. So range would be equal to, u is given to be 16, cos theta is given to be 30 degree, and time, the time of flight in the ocean is given to be 4 seconds. So let's try to solve it. 16 cos 30 is root 3 by 2 multiplied by 4. So that will be equal to 32 root 3 meters. So this will be the answer. So range is 32 root 3 meters. I hope, students, you are totally convinced, right? So it's very, very simple, just by using equations. equations of motion, such questions can be easily solved. But I will recommend you to draw diagram while solving such numericals. That will give you a clarity in your mind. Right? Okay students, so we are over with this particular numerical. The second one is similar question, but in that case, I think the height of the tower is given and we are supposed to find out the time. Right? So let's attempt the second numerical. Just reading the question for you. Question is, from the top of a tower, this height is given to be 156.8 meter. A projectile is thrown up with velocity of, height is given to be 156.8 meter. Right? This is the second question we are attempting. And velocity, it's given to be 39.2 meter per second, making an angle of again 30 degree with the horizontal and thrown up like this. So it will follow a path like this only. Okay. Now calculate the distance from the foot of the tower where it strikes the ground. So this distance is to be calculated. This is the point where the projectile is striking the ground and this is the foot of the tower. So this distance is to be calculated. So R is to be calculated. And the time taken by to do so means the time taken by the projectile to move from O to C. Suppose it is small t. So these are the given informations and total time and the range is to be evaluated, right? Here again students, common sense will come into play. Look at the values, 156.8, 39.2. So what I mean to say is that here G is to be considered as 9.8 meter per second square. That will give us the exact answer, right? Okay, let's proceed. Again, let me convince you. Let us consider the motion. Let us consider the motion of the projectile from O to C, right? Let's consider motion of the projectile from O to C. Since height is given, we need to take this into account, isn't it? So let's consider second equation of motion along vertical direction. Along vertical direction. Let's make use of second equation of motion. It is Sx equals to uxt plus half ax. Actually along the vertical, so we need to consider the y component. Sy is equal to uyt plus half ayt square. Now look, Sy, as I've been telling you for the last few minutes, that in this case this is the origin, and when it is thrown up making angle theta, then it will follow a path like this. So during this time it has covered a vertical displacement h towards the negative y-axis. So Sy would be equal to minus h. What is uy? Initial vertical component of velocity. It is u sine theta. T is the total time taken by the projectile to move from O to C. Plus half ay. Students, initially the projectile is moving upward, so ay is minus g. And then t squared. Right? So let's substitute the value. Minus h is given to be 156.8. U is given to be 39.2. 30. Theta is 30. Sine 30 is half into t minus half 9.8 into t square. I think it will be a quadratic equation in t, right? Let's do it. 156.8 is equal to, it will give us 19.60 minus 4.9 t square. On rearranging terms, what you get is 4.9 t square minus 19.60 minus 156.8 is equal to 0. So there is a quadratic equation. We can easily get the value of small t by splitting the middle term. So let's try to solve it. Dividing throughout by 4.9, what you get is t square minus 4t minus, I think, 32. It is equal to 0. What I have done is, I have divided throughout by 4.9. 4.9 into 4 is 19.6. 4.9 multiplied by 32 is 156.8. Right, students? So now it becomes easy to split this term. So the equation is t square minus 4t minus 32 is equal to 0. So 8, 4, 32. So let's try to split it. T square minus 8t plus 4t minus 32 is equal to 0. So t can be taken as common, plus 4 t minus 8. So that will give us t plus 4 and t minus 8 is equal to 0. Right? So therefore t is equal to 8 seconds or t equals to minus 4 seconds. Obviously time can't be negative. So the time of flight is 8 seconds. So students, the projectile must take 8 seconds to move from O to C. C is the point where the projectile strikes the ground. Right? So time of flight is obtained to be 8 seconds. So this is the answer of the first part, which is the time of flight. Now we are supposed to determine the range as well. So let's try to find out the range. Range means it's the horizontal distance covered by the projectile in the time during which it remains in air or space, which is 8 seconds. So here we have to consider motion from O to C along horizontal. So we'll consider motion from O to C along horizontal. So let's make use of second equation of motion, obviously. Ax is 0, we all are aware of it. Sx, that's range, total range, r. This is the total range, right? Ux, it is u cos theta, initial horizontal component of velocity. T, Ax is 0. Ax is equal to 0. So this term gets eliminated. So let's substitute the value. What is u? It's given to be 39.2. Cos theta, cos 30 degree, multiplied by t, time of flight, it's obtained to be 8. So r would be equal to 39.2, cos 30 is root 3 by 2 into 8. So that will give us 39.2 multiplied by 4 root 3. Am I clear, students? So that will give us 156.8 root 3 meters. So this is the answer. This is actually the range of the projectile. Clear, students? So I hope you have understood these two numericals which were based on case 5. Right? So that's it for this particular session. So do practice such numericals. These are some very, very important numericals which will be very frequently asked in various competitive examinations, right? So do practice as many numericals as possible. So that's it for this particular session. In the next lecture, we'll discuss case 6. That's the case of projection on an inclined plane. That's again a topic which is very important from competitive point of view. Basically, it's important from IIT point of view, right? So anyway, do join me in my next lecture. Till then, do take very good care of yourself. Thank you.